Section 11.2 is over the analysis of variation. So what we've got now is what we call an Anova test. That is the analysis of variation. So it's a very strange acronym. Anova comes from analysis of variation. So it's very strange. It's created with those words or those letters from that phrase. And it's a procedure for comparing the means of several groups. It's a more powerful approach than the Bonferroni correction that we talked about in section 11.1. If there really is a difference in the means, the Anova has a better chance of finding it. And it lets us reach the same result with fewer tests and less error. So we certainly don't want to be doing all of those multiple comparisons if there is a faster way and a more successful way that we can do it. So what we will be specifically studying in this course is what we call the one-way analysis of variance. So we're going to be comparing the means of one variable across several different groups. So again, there are two-way ANOVAs, but we're just doing intro to statistics here, so we are just going to focus on the one-way ANOVAs. Your null and your alternate hypothesis are the same for every Anova test. Now, they're the same, but there's two different ways you can write them. There's more the written out word way you could write them, and then there's also kind of more the symbolic way you can write them. So one way you could write a null hypothesis is you might say that there is no association between the categorical and the numerical variable in question. Now, number-wise, what that means is that means all of the means are the same. However many you might have. So you don't always have to write both of those versions, but they both mean the same thing. If there's no association between the two variables, then all the means will be the same. Your alternate then would be that there is some kind of an association between the variables. And what that would mean is that at least one of the means is different. You have to write it that way because it doesn't mean that they're all different. It means just at least one of them is different from the others. So you cannot write it like this. That is not how we want to write that, because again, that would be implying that every one of them is different from the other ones. But all we're finding out is if they're not all the same, then that would just simply mean at least one of them is different. Maybe it's one, maybe it's more than one. So thinking about that idea, then rejecting your null for an ANOVA becomes somewhat unfulfilling, because all you do is you learn that at least one of them is different from the others, but you don't learn which one it was, or whether it was just one or more than one. You don't learn which mean is the largest or the smallest. So for this reason, your Anova test is often followed up with a further exploration, and we'll get into that in section 11.4, but for now, we will just stop. So visually, what are we looking for? Well, we're comparing the variances of the groups. So if at least one of the means is very far from another, we would want to reject the null hypothesis. And very far means it's relative to the amount of variation within the data. So let's look at a couple examples, just visually. So first we have 4 different groups being compared. And what we can see is that there is a large variation within the groups, right? From here to here, like the groups themselves are very spread out. However, the means of the groups are marked here. Relative to the amount of variation that happens within each group, the means are fairly close together. So this would be a case where there is very little difference in the means. So this would be a case when we would fail to reject the null, right? Because the null is saying that all the means are basically the same, which is what it looks like we have here. Now in the third one, in the second one, notice that the variation within each group is very small. Each group is lumped together pretty close. And relative to that, the means seem like they're very different from each other. So this would be a case when we would reject the null. It does not look like these means are the same. It looks like they are different, so we would reject the null hypothesis.